Common types of pneumatic actuators is the diaphragm actuator. In a diaphragm actuator, air pressure acts on a flexible diaphragm to position a valve. A single-acting diaphragm actuator is called single-acting because air pressure acts on only one side of the diaphragm to position a valve. A typical single-acting diaphragm actuator consists of a casing, a diaphragm, an air supply port, an air vent, a spring, a stem, and a valve position indicator. The indicator shows the position of the valve. The center of the diaphragm is supported by metal plates, and the outer edge is sandwiched between the rims of the upper and lower halves of the casing to form an airtight seal. This arrangement divides the casing into two chambers, an upper chamber and a lower chamber. The upper end of the actuator's stem is connected to the metal plates in the diaphragm, and the lower end moves the valve disc. When the actuator receives a signal from a controller to close the valve, air pressure is applied to the upper chamber, the diaphragm and the actuator stem are pushed downward, the spring is compressed, and the valve closes. Air in the lower chamber is exhausted through the air vent. When air pressure to the upper chamber is reduced, the spring moves the actuator stem upward, and the valve opens. These actions make stem movement and therefore valve position proportional to the amount of air pressure applied to the actuator. Controlling the applied pressure enables the actuator to position the valve anywhere within the limits of travel for the actuator. This type of actuator can be called an air-to-close, spring-to-open actuator because air pressure moves the stem to close the valve and a spring moves the stem to open the valve. This means that if air pressure to the actuator is lost, the control valve connected to the actuator will fail open, since spring pressure would raise the stem and open the valve. A single-acting diaphragm actuator that's designed to close a valve or fail closed when air pressure is lost looks like this. As you can see, it's very similar to the actuator we just looked at. During operation, air pressure is fed into the lower chamber. This causes the diaphragm to lift, which expands the spring, raises the stem, and opens the valve. When air pressure is reduced, the spring pulls the diaphragm and the stem downward, closing the valve. A control valve using this kind of actuator is said to fail closed because if air pressure is lost, the spring in the actuator will close the valve. A diaphragm actuator with an air line to only the lower chamber is typically an air-to-open, spring-to-close type, which causes a control valve to fail closed. An actuator with an air line to only the upper chamber is typically an air-to-close, spring-to-open type, which causes a control valve to fail open. By controlling the applied pressure, either of these actuators can be used to position a valve anywhere within the limits of travel for the actuator. Regardless of how they operate, single-acting diaphragm actuators are usually represented on process piping diagrams by this symbol. A double-acting diaphragm actuator is called double-acting because air pressure acts on both sides of a flexible diaphragm to position a valve. A double-acting diaphragm actuator consists of a casing, a flexible diaphragm, an upper air supply port, a lower air supply port, a stem, and a valve position indicator, which shows the position of the valve. The center of the diaphragm is supported by metal plates, and the outer edge is sandwiched between the rims of the upper and lower halves of the casing to form an airtight seal. This arrangement divides the casing into two chambers, an upper chamber and a lower chamber. The upper end of the actuator stem is connected to the metal plates and the diaphragm, and the lower end is connected to the valve stem. When air pressure is applied to the upper chamber, the diaphragm and the actuator stem are pushed downward, and the valve closes. Air in the lower chamber is exhausted through the lower air supply port. When air pressure is applied to the lower chamber, the diaphragm and the stem are pushed upward, and the valve opens. Air in the upper chamber is exhausted through the upper air supply port. These actions make stem movement and therefore valve position proportional to the difference between the two air pressures applied to the chambers of the actuator. Controlling the applied pressures enables the actuator to position the valve